This is P.V. Sudarshan from the Department of Chemistry, St. Joseph Pre-University College, Bangalore. In today's session, I will be sharing with you some of the concepts of inorganic chemistry to strengthen its hold and to do better in your CET examinations. Our first question. The sulfate of a metal has the formula M2SO4 thrice. The formula of its phosphate will be. Now, what is the appropriate answer for this? For this, you need to know what is the charge on the metal, what is linked with the metal. So, let us start working to understand how to solve these type of problems. I have the formula as M2SO4 thrice. I understand by this combination, we are aware in your lower classes you have studied how to write the formulas. Therefore, here if I happen to write, this is arrived by writing as M3 plus SO4 2 minus. Now, how did I get this formula M2SO4 thrice? I understand that it is SO4 3 times, therefore, it is M3 plus SO4 it is 2 minus. Now, the question says the sulfate of a metal has the formula M2SO4 thrice. The formula of its phosphate, meaning metal is linked with its phosphate. Now, I understand my metal happens to be M3 plus, no doubt about it. My phosphate, which is PO4 3 minus. Now, I understand 3 plus and 3 minus get cancelled. Therefore, my answer is MPO4. Therefore, the correct answer in this option A, B, C and D happens to be option D, MPO4. Therefore, option D is the right answer. Next question. Elements belonging to the same group of the periodic table have option A, same number of energy level, option B, same number of valence electrons, option C, same ionization enthalpy, and option D, same atomic radii. Let us understand the concept behind this question. In a group, we know that in a group, as we move down the group, elements in a group, the number of valence electrons remain the same, but the distance from the nucleus to the outermost energy level increases, meaning atomic radii considerably increases, while number of valence electron in it tries to remain the same. As I move down the group, I am moving from first energy level to second energy level to third energy level and so on. Therefore, energy levels also will considerably increase. Then how about ionization enthalpies? Ionization enthalpy is the amount of energy required to remove the electron which is present in the outermost energy level. I understand. As I move down the group, the number of valence electron repeatedly I am telling remain the same, but the amount of energy required to remove an electron changes considerably because the distance between the nucleus and the outermost energy level increases. Thereby, I would like to confirm 101 times to you and then tell that in a group, the number of valence electron remain the same. It is one and the same for any group that you consider in the periodic table. While atomic radii varies, ionization enthalpy varies, energy level also varies and increases considerably. Therefore, the correct answer is in this same number of valence electron. Option B is the right answer. Next question. Which of the following has the lowest electron affinity? Option A nitrogen, B oxygen, C argon and D boron. Try to understand what is electron affinity. Electron affinity is the energy changes that takes place when an electron is added to the outermost energy level. I am repeating, energy changes that takes place when an electron is introduced or added to the outermost energy level. In that case, if I happen to consider nitrogen, oxygen, argon and boron, it immediately strikes to my mind that argon belongs to group 18. There are no valence electron. The outermost energy level is completely filled with electron. There is no possibility of adding another electron. Therefore, I would say the lowest electron affinity would be for argon. Electron affinity is relatively 0 for it. The correct option under this A, B, C and D is option C, argon is the right answer. Similarly, now let me try to change this question. Which of the following has the highest ionization enthalpy? Without writing the question, let us try to understand with the same options if the question is altered. Ionization enthalpy. Ionization enthalpy is the energy changes that takes place when an electron is removed from the outermost energy level. I would rather put it up like this: amount of energy required to remove an electron which is present in the outermost energy level. Under this, I have nitrogen, oxygen, argon and boron. If I happen to consider only nitrogen and oxygen, forgetting about argon and boron, I would preferably say between nitrogen and oxygen, nitrogen, it is highly stable because it is half filled p orbital. Therefore, it is not easy to remove an electron. So, comparing nitrogen and oxygen, nitrogen has got highest ionization enthalpy. Hope you understood the concept of electron affinity and ionization enthalpy. Dear students, I hope you would have understood the concept of ionization enthalpy and electron affinity. Keeping these two in mind, let's try to answer this question. The element having very high ionization enthalpy but 0 electron gain enthalpy is, little while ago I said, noble gases, that was argon which we discussed, electron gain enthalpy was 0. And then I said nitrogen, because of its half filled extra stability, it has got very high ionization enthalpy. Now, keeping the same concept in mind, the element having very high ionization enthalpy but 0 electron gain enthalpy is your option A hydrogen, B fluorine, C helium, D beryllium. The right answer, I suppose you should be telling it now on your own, is by all means it is helium, option C. Reason for it, you know, helium electronic configuration, stable electronic configuration. Therefore, it is difficult to remove an electron from its outermost energy level, understanding that it has got high ionization enthalpy. Then it cannot accept an electron. Electron cannot be added to it. Therefore, its electron gain enthalpy happens to be 0. Therefore, the right option is option C, helium. Our next question. Which of the following ions contain maximum number of unpaired electrons? To understand this question, you need to know the electronic configuration, how the electrons are distributed in various energy levels. By all probability, you have the options as iron and cobalt, both of them belong to d block elements. That is, d orbital is getting filled. If d orbital is getting filled, how do I write the electronic configuration? Let me try out for iron. Iron, Fe, atomic number is 26. When I write the electronic configuration, I write it as argon. Up to argon it is 18. Then I have 4s2, 3d6. Hope you are aware of how to writing the electronic configuration. Next, when I try to write for Fe2 plus, understanding that 2 electrons are removed from its outermost energy level. If 2 electrons are removed from its outermost energy level, then the configuration would necessarily be 3d6. If it is 3d6, when I try to accommodate 6 electrons in the d orbital, I understand I have to fill it in this format: 1, 2, 3, 4, 5, 6. The number of unpaired electron in this case is 4. Similarly now, if it is Fe3 plus, I understand that 3 electrons are removed from its outermost energy level. Therefore, these 3 electrons are from S as well as from D, 2 electrons from S and 1 from D. Therefore, my configuration is 3d5. If it is 3d5, I understand that there are 5 unpaired electrons. Hope you are getting the clue now. Now, let me try in the similar fashion for cobalt. Cobalt, whose atomic number happens to be 27. Now, how do I do it? I do it like this. Argon again, I write it as argon, 4s2, 3d7. I want it for CO2 plus. By now you would have understood how I solve for iron. Help me out. Therefore, 2 electrons are lost, understanding that the configuration is 3d7. If it is 3d7, how do I fill up? Up to here I filled up 6. Next one would be 7. Therefore, number of unpaired electron in this case will relatively be 3. Hope you got it. Similarly, CO3 plus. If it is CO3 plus, 3 electrons are lost. If 3 electrons are lost, 2 from the s orbital, 1 from d orbital. Therefore, the configuration happens to be 3d6. If it is 3d6, we have come across that the number of unpaired electrons happen to be 4. Now, by all probability, I have which of the following ions contain maximum number of unpaired electrons? I have for Fe3 plus, there are 5 unpaired electrons. Therefore, option B, Fe3 plus is the right answer. Our next question. Which of the following is isoelectronic with hydride ion? Meaning of isoelectronic. Isoelectronic are those species where the number of electrons are same. Simple as it is. Now, hydride ion. Hydride ion happens to be H minus. Hydride ion is H minus. Hydrogen 1. Because there is a charge on it which is minus, therefore I add another electron, therefore total number of electron that it has got is 2. Now, when I compare it with option A lithium, I know that lithium, it is 1s2, 2s1, 3 electron, not matching. Similarly, when I have helium, He2, it is 2, because the charge is plus, I have to minus 1, it is 1, therefore even that is not matching. When I say it is helium, electronic configuration happens to be 1s2, 2 electron, matching to my hydride ion H minus. Therefore, the correct and the right answer is option C, helium. Let us again take another relevant example. If I give you carbon, carbon would be isoelectronic with, example I am repeating, carbon would be isoelectronic with, carbon would be isoelectronic with, I would say it is N plus. How do I justify my statement? Carbon 6 electrons, fine. Nitrogen 7 electrons, because the charge is plus there, I minus 1, therefore it becomes 6. Carbon is having 6 electron, nitrogen N plus is also having 6 electron, carbon is isoelectronic with N plus. Hope you have understood this question. Next question. The paramagnetic species among the following is, to solve these type where it is diamagnetic and paramagnetic, understand one simple logical concept. The concept is, try to find out the total number of valence electron. Sometimes it would be difficult for us to remember the atomic number and work accordingly. Follow the tip that I happen to say now. Now let me take for KO2. I have option A, KO2. I understand potassium plus 1, its valence electron. Oxygen, remember, belongs to group 16, so do it as 6 into 2, 12. Meaning to say it like this, I am working out for you, I am having it as KO2. I write it like this, valence electron 1, oxygen 6 into 2, 12. So, total number of valence electron happens to be 13. Hope you got it. Similarly, I am doing for SiO2. Silicon belongs to group 14. Therefore, number of valence electron happens to be 4 plus 6 into 2, 12. Therefore, understanding that 16 is the number. Coming back again, TiO2, titanium, belongs to group D. I understand that it has got D2 configuration, therefore it is 2 plus 6 into 2, 12, happens to be again 14 electrons. BaO2, again barium, I know it is 2 plus, therefore plus 2 plus 6 into 2, 12, again I get 14. By looking at all these numbers, I understand that KO2 is an odd number. Paramagnetic species is that which has got odd number of electrons when I happen to calculate with respect to the valence electron. Therefore, the paramagnetic species among the following is, it is option A, KO2. The previous question on how to judge whether it is paramagnetic or diamagnetic, this question should be relatively easy for you. It is a practice question for you. Now, how will you attempt? Which of the following oxides of nitrogen is paramagnetic? I gave you one simple concept. Calculate the total number of valence electrons. Add up the total number of valence electron. Judge it based upon whether it is an odd number or even number. If it is an even number, it is diamagnetic. If it is an odd number, it is paramagnetic. Simple concept again. I have here oxides of nitrogen. Nitrogen belongs to group 15, understanding 5 valence electron. Oxygen belongs to group 16, understanding that there are 6 valence electron. Therefore, wherever there is nitrogen, I take it as 5. Wherever there is oxygen, I take it as 6. This is the only concept that you need to know. Wherever there is nitrogen, you are taking it as 5. Wherever there is oxygen, you are taking it as 6. So, let me make an attempt for this. N2O, I remember telling you nitrogen is 5. 5 into 2, 10. 10 plus 6, it is 16. Option B, 5 into 2, 10. 6 into 5, 30. Therefore, it is 40 electrons. Nitrogen 5. Oxygen 6 into 2, 12. Total number of valence electron 17. N2O3. N2 nitrogen 5 into 2, 10 plus oxygen 6 into 3, 18. Therefore, I have 28. From this, I understand that which of the following oxides of nitrogen is paramagnetic. N2O, it is even number having 16. N2O5, even number 40. NO2, it is odd number 17. N2O3, even number 28. I said that odd number is paramagnetic in nature. Therefore, my right answer is option C, NO2 is paramagnetic in nature. Our next question, identify the alkali metal ion having greater degree of hydration. All the options that you have are alkali metal ions. A simple concept you need to know. Smaller the size of the alkali metal ion, greater is the degree of hydration. Repeating the statement. Smaller the size of the alkali metal ion, greater is the degree of hydration. Keeping these alkali metals in mind, I have Li plus, Na plus, potassium and rubidium ion. Now, understanding that alkali metal ions, these belongs to group S, lithium, sodium, potassium, rubidium and cesium. The smaller metal ion in this case happens to be lithium. Therefore, the right answer is Li plus. Option A is the correct answer. Our next question, sodium forms Na plus ion, but it does not form Na2 plus ion because the options that are being given here are with respect to ionization enthalpy. We are aware sodium, atomic number 11, you get the configuration as 3s1. When it is 3s1, it is easy to remove an electron in the s orbital. Therefore, it requires low ionization enthalpy. By removing 3s1 electron, I get the configuration as for Na plus, atomic number 10, the outermost energy level would have attained octet configuration. Because the outermost energy level has attained an octet configuration, it is not easy to remove an electron from the outermost energy level. Thereby understanding that Na plus requires low ionization energy of the first format. When I want to remove another electron, because it has attained stable electronic gas configuration, therefore, it is difficult to remove an electron. Therefore, my right option would be option D, low value of first ionization enthalpy and high value of second ionization enthalpy. Option D is the right answer. Dear students, we are aware that sodium, atomic number 11, it has got 3s1 configuration. It is easy to remove an electron. First ionization enthalpy is low. When I want to remove another electron, it would have attained, sodium has attained a noble gas configuration. Outermost energy level is completely filled with electron. It requires very high second ionization enthalpy. Therefore, right answer is option D. Our next question. The hydride from amongst the following that cannot be obtained directly by reaction with hydrogen is? A basic concept here. All alkaline earth metals undergo reaction with hydrogen to form hydrides, exception to beryllium. So, hope you got the answer now. All alkaline earth metals undergo reaction with hydrogen to form hydrides, exception to beryllium. If that is the case, in this case you have option A CaH2, option B magnesium hydride, option C beryllium hydride, and option D sodium hydride. Option C beryllium hydride is the right answer. However, another beautiful concept for you to learn and understand. Though I said beryllium hydride cannot be prepared directly, but it can be prepared by taking beryllium chloride. It can undergo reduction using lithium aluminium hydride to form hydride of beryllium. So, point to be noted, alkaline earth metals undergo reaction with hydrogen to form hydride, exception to beryllium, that is beryllium hydride cannot be prepared directly by combining with hydrogen. However, beryllium chloride can undergo reaction with lithium aluminium hydride to form beryllium hydride.